In this episode, let's make Lego bricks out of aluminum. Okay, so I want to make a few Lego bricks out of metal on the DMC2. This is a cool project because while Legos seem simple, they actually are very precisely shaped plastic parts. If you think about it, for each Lego to stick together with a friction fit with other pieces using just the tiny nubs at the top, they need to be manufactured to very tight tolerances. Making Legos on the DMC2 is an interesting way of testing the machine's ability to manufacture precision parts. And on top of that, the task becomes more difficult when you're making them out of metal instead of plastic, since there's less flex in the material and you can't just shove the parts together and let the walls deform to accommodate for any oversized or undersized mating features. So I've got this piece of aluminum that I've modeled in Fusion 360, and I figured I could just fit 8 blocks of Lego inside of them. These aren't standard sized blocks. I designed them myself to be approximately 20mm by 40mm. They're a tiny bit undersized, that way they can actually stack side by side with a tiny clearance gap between. The pitch of the Legos, or the spacing between all the round mating components, is exactly 10mm though. Once I have my 8 Legos spaced out in CAD, my plan is to start off machining with a 4mm end mill to face off the top of the stock and remove a majority of the material from the inside of each Lego, and then switch to a 2mm tool to do the finer inner details. After that, because of the height of the Legos, I'm going to switch back to the longer 4mm tool to contour them out, but leaving tabs at the bottom so that they don't come loose as they're cut and go flying around. When I'm done with that, I'll come in with a chamfer tool to break the edges on everything so that the Legos connect together smoothly without any sharp edges catching. Over on the CNC, to mount this chunk of material, I'm not going to use the vise. If I did and then removed all the material in the middle, there's a chance the entire piece of stock could lose its stiffness and sort of collapse in the vise and come loose, which would be disastrous. This is something to always keep in mind and avoid if you're machining a lot out of the center of a piece of material. Instead, I'm going to do something called the superglue and tape trick. Basically, I'm using a thick high-strength tape, in this case 2mm powder coating tape, and taping both the bed of the machine and the bottom face of the piece of stock, and then supergluing the two together. This works very well for flat sheet material and lets me machine safely all the way down to the bottom without compromising the holding strength or hitting the vice jaws in some situations. The one tricky thing with this method is that you need to clean the bed and the part very well so that the tape sticks. I wiped down the CNC bed and then used some generic alcohol prep pads to wipe the surface clean and get all the oily coolant residue off. Once the surface is clean and dry, I can lay out the tape and press down to make sure it bonds securely to the surface. You can actually see the color change and darken a little bit with this green translucent tape, which helps. Next, I'm using superglue and spreading glue on the tape, and then quickly putting the stock material on and pressing while the glue dries. You may have noticed, but this isn't the actual piece of stock for the Legos that I have modeled. This is just a similar example from something else. I actually forgot to hit record when I was setting up the Lego stock. Anyways, back to the actual Lego stock. I have it glued down and I'm setting the work coordinates somewhere vaguely around the bottom left of the part, or from your camera perspective that's top left. The X and Y coordinates don't matter much since the material is oversized, but the Z height is critical, so I'm using the Z height buck to automatically set the tool height. You need to set the tool height anytime you change tools on the DMC2. So with the 4mm end mill set, we're ready to go. And, whoops, a little too high on the feed rate. So I'm going back to the first setup. This is everything that happens with the 4mm tool in one G-code file. I'm using an adaptive toolpath to remove the material off the top of the Legos, but I've modified it to be a little less aggressive than last time and in 2 passes. After that, the tool will contour down in a ramp on the insides of the Legos, first following the outer perimeter and then following the inner little island for each. Finally, I'm using a bore operation to ramp down and clear out the middle in each hole. I can see this in the simulation, which shows everything the CNC will do. Now that I'm done with the 4mm end mill, the 2mm end mill can be swapped in for the next set of operations. I do need to reset the Z height again for the new tool. There is one very important thing to catch here in the cam setup. Previously, the parts were set up in the stock aluminum, sort of floating in the middle, so there was stock on the top to be removed, and the 4mm tool had to be zeroed on the top of that extra material. Now that it's being faced down, the new top surface is the actual Lego bottoms themselves, so my stock setup has been changed to reflect that. You can see that I have the origin moved down and the stock material shortened to the new exact height. Now that that's good, I need to have a clean surface on the part to zero off of. I use the brushes that come in a keyboard cleaning kit for this kind of thing, and you'll definitely want to pick up a $5 set of brushes because you constantly need them for these kinds of things. So with the 2mm tool, I'm doing just a slight cleanup on the small features and removing whatever material the 4mm tool couldn't get to. Now that that's done, I'm switching back to the 4mm end mill to slot out the Lego bricks themselves. I'm doing this first with stock to leave turned on, and this will leave a small amount of material uncut on the walls of the Lego as it ramps down. And then in the second contour, I'm cutting that extra material out at a much slower feed rate, which will leave a nice clean surface on the side to the Lego, and no marks that typical slotting down steps leaves. Something I want to point out is that in the first ramping down contour operation, I have tabs turned on, and I've set a tab height of 0.5mm and 4mm wide. These are arbitrary numbers, but over time I've figured out that they work well. The parts are glued down, so maybe I could get away with no tabs, but because they have such a small surface area, I don't quite trust that each one has enough glue under it, so I'm leaving very thin tabs in place at the bottom of the stock material. Tabs of this thickness I found are very easy to remove afterwards. The second contour operation does not go down to the full depth, or else it would cut off the previous tabs. Instead, it only goes down to the top edge of the upside down Lego walls, since that's all it needs to cut. So over on the machine, once again, load the tool, zero the tool, and then click start on the new program. By the way, I should mention that between running all of these different G-code files for each tool, I am not changing the X and Y coordinates that were set up the first time over the bottom left of the part. Since each file is set up with the exact same X and Y coordinates, I only need to update the Z height each time I change a tool. The downside with this is that if something were to crash and stall mid-cut, or for example there was a power outage, I would lose that saved X and Y position. I'm not really worried about that, and I'm fairly confident in my cam skills, and these parts are not devastating or expensive to lose, so I'm willing to take that small risk for the effort it saves. That being said, I did crash and break an end mill earlier, but the machine did not actually lose its position, so it was fine. I hit the E-stop, so nothing should have slipped and lost position at that moment. So cleaning everything off again, I can swap to the chamfer tool and reprobe off the top surface again. And this chamfer is just a tiny 0.05mm edge break on everything. So now is the satisfying part of removing the stock material. I use a small sharpened pry bar kind of screwdriver to pry the material up, and if you're careful you can do this without damaging the bed or the stock material. And this is exactly what I wanted. When you correctly measure the stock material, you can cut through the material through the first layer of tape and not through the second layer onto the CNC bed, which is the most ideal situation. Using thicker 2mm powder coating tape versus the cheaper 1mm also helps by increasing the tolerances you have to work with. I'm rinsing these parts off in a bucket of water. You definitely don't want to wash them in a sink because all the little chips will immediately clog the drain. Again, those keyboard cleaning brushes really come in handy. So now this is why I left specifically 0.4mm thick tabs. Using a pair of flush cutters, it's very easy to snip off the tabs and even trim the remaining debris off to a clean finish. You can also see how the wall is a little cleaner where it had the cleanup contour, but I think it still went a little too fast because usually I can get more smooth and shiny results than this in aluminum. With all the blocks cleaned up, all that's left to do is machine the tops, but for that I'm going to use the vise. To put the vise back on the machine, I need to clean off the bed from any chips, and since I've left the dowel pins in, all I have to do is slide the vise between and bolt it down evenly. I'm using the tallest parallels I have to bring the Lego block up, and I'm using a third parallel on the side to make sure that the far side of the Lego block is flush with the side of the vise. It takes 3 hands to do everything and tighten the vise at the same time, but you get used to it. The reason I'm aligning it to the side of the vise is so that I can swap each brick in one after the other in the same position without needing to reprobe after the first time. Now for this top operation I'm using a 3mm end mill, and I'm doing an adaptive clearing with a small stock to leave to clean up the majority of the material, and then a slower contour to get the circles into final dimension. And finally another adaptive to trim the tops down to their final height. I also have the work coordinates set to the bottom left of the part, and usually you have it somewhere on the top of the part, but because the bottom surface of the Legos are known and machined and the top is just raw, bumpy stock, it's more accurate to measure off the bottom in this case. I'm doing a little trick here where I set the height buck on the parallels to capture the bottom surface. For the X and Y faces, I can just use the probe and carefully jog to each face without hitting the vise, and being careful to actually touch the face and not any bumpy debris from the tabs that were cut off at the top edge. Now that I have the first CNC Lego, the first thing I want to do is see if they stick together. And yeah, they don't. I kind of suspected this. When you have two things that fit together, you need to have clearance between them to fit. Otherwise it's an interference and you risk something grinding together and shearing off some material. With Legos, you want to have some clearance, but not so much that it's loose. And at the same time, you don't want a grinding interference, but a very slight touching interference. This is what makes Lego so challenging to CNC machine and get right, which is why I chose this project. So here's the trick I'm using to get the fit that I want. I want the CNC to cut slightly deeper into the diameter of the Lego top circle extrusions, so I could go back to CAD and adjust this and reload the cleanup contour, but a quicker way that is often easier than going back and editing a complex CAD model is to just duplicate the setup and delete the operations I don't want, and then click on Tool, click on Documents, and then find the exact tool I am currently using. I can then right-click Edit Tool, and then change the diameter to something slightly smaller, like 2.95mm for example, and then Accept. This does not edit the original tool stored in my library, but just makes a copy saved within this CAD part file. Now I can send this one setup over to the machine, rerun, and see if I get the fit that I want. Once I'm happy with it, I can change the diameter again in the original setup, and now run the rest of my Lego blocks with the perfect fit. Now I'm getting the fit I want, maybe even a little too tight, but it seems good enough. When one Lego brick is done, all I need to do is remove it and reinstall the next one and hit cycle start. The X, Y, and Z axes are all already set since each block is identical and in the same position. So let's see how they work. The Legos fit together great, but they definitely take more force than normal plastic Lego, but that kind of makes sense since the metal is less flexible. You'll notice I only have 5 here out of the original 8, and well, that's because I adjusted the tolerances 3 times to get it exactly how I wanted, so those 3 didn't fit very well. Also, since I reduced the outer dimensions from that nominal 20 by 40mm, there's that tiny bit of critical clearance between them so they can stack side by side, which is very satisfying. So that's it for this video. Hope you enjoyed it, and hope you learned something new. See you in the next one.